Hello everyone, this is Data 620 Project 2. Uh, this is basically an analysis of two-mode network of Facebook-like forum communication data. Warner Alexis and I worked together on this project. So at first I'm going to mention the assignment details, and here are the assignment details. Basically in this assignment we have to identify a large two-node network dataset, and the data should meet the criteria that it consists of tie between and not within two distinct groups. Also, we have to reduce the size of the network using a method called island, and then we have to infer about each of the distinct groups. So here is the introduction part. So basically in this project we utilized Facebook-like forum network dataset. The dataset was attained from the same online community, the online social network, and is now available at storyofcell.com. Here's the link you see. And the dataset is a weighted static two-mode network dataset. Here, what it means the number of messages that a user wrote in a particular thread. So tie basically here represents uh, how many messages a user posted in a specific topic, and in this network a weight is assigned to the ties based on the number of messages that a user posted to a topic in an online forum. So this is basically a users and topic interaction dataset. So this makes this dataset a suitable one for our analysis, as it captures relationship between two distinct groups, user and threads, rather than within them. And then we imported a couple of libraries for this analysis. We used pandas, networkx, matplotlib, and also we utilized networkx.algorithms. From here we imported bipartite, and then we loaded the dataset from our GitHub, from my GitHub, and then we loaded the dataset for checking purpose. And as you see here, the number of users in this dataset is 899, and the number of threads is 522, and the number of ages is more than 7,000. Then we created a weighted bipartite network. At first we defined the graph, which is denoted by B here, and then we added nodes and edges. And if you see the bipartite network that we created, the number of nodes is 899 and the number of edges is 7046. Then we check basic network properties, and the network density we found here is 10175, and the number of connected component is 1. Largely number of connected component is 1, which means the density 1.75% means that the dataset is network is sparse. That is 1.7% of all possible user thread connections actually exist here. So the users are selective here and post in only a small number of threads rather than interacting with every possible thread. And the largely connected component of 1 means the entire network forms one single connected structure with no separate clusters, subgroups, or isolated nodes. So every user and thread is connected either directly or indirectly within this one big network. And then we reduce the bipartite network using the island method. So to do that, we first define the trim edge function, which basically raises the water level, and that means that it keeps only edges with weight greater than a certain threshold, and returns a new reduced graph, which is basically non-destructive graph. So here is the return graph G2, and then we define the island method function, and this function basically calculates the minimum and maximum edge weights, divides the range into steps for iterations, and returns a list of graphs, and each graph corresponds to one water level. Here we define the island method, and finally we applied the island method to the bipartite network, and you see that we got a couple of islands at a different water level or threshold. For example, we got a threshold equal or greater than 29. We got 103 number of nodes, and we got edges of 113, and also we got number of component here 10. And if you see that at threshold number 57 we got number of node 31 number of nodes, and we got 26 number of edges, and also the number of connected components is 5 here. And there are also other thresholds like at equal or greater 85, equal or greater 113, equal or greater than 141, equal or greater 169. So by analyzing these islands, uh, we selected the 57 threshold because we found that this is the threshold in which the reduced weak connections, which keep the reduced weak connections. I'm sorry, which reduce the weak connections while preserving the meaningful clusters. So at this level, we found the network had 31 nodes and 26 edges, and which formed basically 5 separate groups or islands. And each of the 5 groups or islands represents users who basically interacted frequently in specific threads, and these groups indicate strong engagement and shared interest around certain discussion topics. So the separation into distinct islands shows that community naturally formed smaller active clusters. Weaker or casual interactions were removed, leaving only the core structure of the most active users and threads. And then we define the reduced bipartite network using the selected threshold. So here is our reduced network at the defined threshold of 57. Again, we see the number of nodes here 31 and number of edges here 26, and the number of connected components 5. That means there are 5 groups or islands in this network. So then we identified the users and threads for the reduced bipartite network, and then we visualized the reduced bipartite network. The first one is for the reduced bipartite network of users and threads, and if you see here, this plot shows the simplified bipartite network after applying the threshold of 57. The blue nodes here represent the users, and the green nodes here represent the threads. So only strong connections are retained, showing the core active interactions between users and threads. And then again we visualize the reduced network colored by islands, you see, and these visualization colors each represents each connected component or island differently. The 5 colored groups here represent 5 distinct clusters of strong user-thread interactions, and each cluster shows users engaging with a specific subset of threads, which reveals focused participation patterns. And then we computed top 5 nodes by degree, and he found that the top 5 nodes are here is 100, 107, 117, 13, and 59. Then we visualized the graph again, plotted we here plotted node size by degree. So here the top nodes are showing in red color. You see the top 5 nodes: 59, 107, 107, 113. So here the node size reflects its degree, I mean the number of strong connections. So the larger nodes here indicates key users or threads that are highly connected within the Redis network. So this basically helps identify central participants or topics among the most active interactions. So for the rest of the work, my teammate Warner Alexis will present. So I'm now handing over the presentation to him. So thank you for listening to me.
Hi, good afternoon. So I'm gonna continue with the presentation. So visualization for reduce Bob tight network. So in this section, I am visualizing the reduce bipartite network after trimming the dataset to only include the most significant user and thread. So the blue node on the left represent user, and the green node on the right represent thread or discussion topic. So each leg or line or between them show that a user participate in that thread. So by reducing the network, we simplify the structure and make the relationship easier to interpret. So instead of showing the entire dense network, this visualization highlight a small subset where interaction are more focused or easier to trace. So as we can see, several users are connected to the network, indicating shared activity, overlapping interests among them. So this kind of view help identify key users who participate in multiple threads or popular thread that attract several users. So when we go down to the second graph, so this reduces the Barbite type network and show the interaction between user and discussion thread in the Facebook like forum dataset. So the blue nodes represent user and the green node represent thread and the gray one. So by filtering the most active user and thread, the graph highlight the core community engagement, showing which user participate across multiple discussion and which thread attract the most attention. So this visualization color each connected component or island differently. So the five color group represent five distinct cluster of strong user thread interaction. So each cluster saw user engaging with a specific subset of thread, revealing focused participation pattern. So when we go down to the next graph, so we have the top 5 node by degree, which is 100. We have 107. We have 117. We have 13 and 59. So what we can apply in this graph is that it highlights the most connected node in the widget's Facebook like forum network. So the code size represents each node degree or the node connection it has, while the red color marks the top node by degree. So in this context, nodes such as 100, like we was just saying, 107 has the highest degree, meaning they are the most active thread receiving posts from multiple users. So similarity, 117, 13, and 15 also show strong participation, but this visualization help identify the core discussion thread that drive engagement in the forum, showing where most user interactions are connected. So for this part, so what we do in this code is that we kind of train the bipartite form graph. We separate the two node set using bipartite tag and also build projected graph. So a user to user graph where two users are linked if they when two users are linked if they post in at least the same thread. In a thread graph where two threads are linked if they share at least the same user. So the printout shows the projection of size 8, like we said, the projection size 8, and then the user projection edge, which is 12. So the printout shows projection size 8 user with 12 link. Density is about 0.43, meaning that this core user group participate quite a lot. 31 thread with 33 links. So now we do some statistical thing to kind of calculate the degree of centrality and also the betweenness of centrality. So each user node degree of centrality show how many users they are directly connected to share thread. So his user 704, 719, 841, 867, and 358 have the highest degree of centrality of 0.57, meaning that they often participate in the same discussion, forming a highly connected group. So between centrality, so which measure how often a user act as a bridge between others. So it's generally low, indicating that interactions are clustered rather than passing to intermediaries. So also you have other detection resulting in two main user groups. You have community one, which composed of some user 841, 358, 704, and 719. So these users, there are a tiny kit set of users who frequently post in the same thread. And also we have community 2, which is a small subgroup of their own that share certain activity pattern. So the thread to thread centrality. So thread like 100, 18, 17, 289, 82, 377, and 358 have the highest degree of centrality, meaning that they share participant with many other threads. So these are likely the most active or popular discussion topic that attract overlapping user. So between us, centrality value are low overall, suggesting limited bridging role between separate discussion cluster. And then with these graph, so with the other two graph, so we can see that the inference we make is that user from 704, 719, 841, 867 are tightly connected and frequently post in the same thread. So they form a major cluster representing shared interests and consistent interaction. So user 100, 810, and 53 form a smaller cluster with fewer connections. So user 810 act as a bridge between the two clusters, so helping information flow across community. Overall, the user network show or active participant or group and how some users are connected within each other. So the two-mode network analysis of Facebook to finish it. So what we realize is that the two-mode network analysis data show clear interaction pattern between user and thread. This projection on the user network identify active user and cohesive subgroup, while the thread projection highlight which discussion group attract share participant. So after applying the island method, the reduced network focus on the strongest relationship, simplifying the whole structure and emphasizing the core of community activity. Overall, this data set demonstrate or bipartite network analysis can help with both social cluster and topic of interconnection while online and communicate with the system. Thank you.